Hello everyone, welcome back to another video with K Solutions. In this video, we'll be simplifying the exponents of x squared times y to the third power divided by x to the fourth power times y to the seventh power. The first step in simplifying this equation is using our exponent rules. And the reason I knew to use this is because we have a whole bunch of exponents in this equation and we need to simplify it. So if you're familiar with your exponent rules, I can easily identify that we need to use the quotient rule because we have division in our problem. Yes, we also have multiplication, so we could use the product rule. But if you look at the product rule, it's saying you must have the same variables to different exponents. In this case, being multiplied by each other. So the same variable being multiplied by each other. In this case, we have different variables being multiplied by each other. We have x times y on top and bottom. What the product rule is saying, x needs to be times x or y times y. So the quotient rule is saying, long as we have the same variable being divided by each other, which we do, we have x divided by x, one on top and one on bottom, and we have y divided by y. And it may be a little bit easier to see that if you split the fraction. And you can easily do this because the variables are being multiplied by each other. So you can split that fraction up. So you can just say x squared divided by x to the fourth power times y to the third power divided by y to the seventh power. And maybe that's a little bit easier to read to use your quotient rule, because now I have the same variable being divided by each other, but with different variables, with different exponents, I'm sorry. And so now, seeing our equation split, let's use our quotient rule as step number one. So x squared divided by x to the fourth power, that now turns into x raised to the 2 minus 4 power. And I just simply used the quotient rule. I took x to the second power divided by x to the fourth power equal to now x raised to the 2 minus 4 power. And I'm going to do the same thing with my y variables. So I'm going to bring down my multiplication sign, and I'm going to go y raised to the 3 minus 7th power. So just right there, I've simplified this equation. But we can do it a little bit further and simplify the 2 minus 4 and the 3 minus 7 in our exponents. So we can simplify that operation a little bit more. So now that's going to be x raised to the negative 2 power times, simplifying the 3 minus 7, that's now going to give us y raised to the negative 4th power. Okay. Now, we cannot leave our final answer as a negative number, a negative exponent. Our exponents must be positive when we get done. And that's just a rule of the exponents, because we actually have a rule that says negative exponents and how to break that down to make it a positive exponent. So we can't leave it as x raised to the negative 2 power and y to the negative 4th power. We need to do another step. So for each variable, I'm going to use the negative exponent rule. So x raised to the negative 2 power is now going to turn into 1 over x squared. So I took the negative exponent and I made it positive by putting it as the denominator in my fraction. And I'm going to do the same thing to the y and turn it into 1 over y to the 4th power. Okay. Now, again, if you're familiar with your rules of fractions, just the same way I split my fraction up at the top, I can now bring it back together as one fraction. And that's because if you're multiplying fractions, you can multiply straight across. And so 1 over x squared times 1 over y to the 4th power turns into 1 over x squared times y to the 4th power. And that's your answer. Okay. Now, I always like to go back and check my work. And so that's what we're going to do on this side. For our next step, we're going to check our work. And the easiest way to check your work is by inputting numbers into your variables. So instead of saying X and Y, let's give those numbers so we can plug it in and solve for it. So for our first one, we're going to plug in to our original equation. Let's say X is equal to 2 and Y is equal to 3. Okay. And we're going to plug it into our original equation. So instead of saying X squared, I'm going to say 2 to the second power times, instead of Y, I'm going to write 3 to the third power divided by 2 to the fourth power times 3 to the seventh power. And if you were to plug this in and solve your exponents, you would get 2 to the second power is 4, 3 to the third power is 27, over 2 to the fourth power, 16, and 3 to the seventh power is 2,187. Okay. Then if you're to solve that even more, you would get 4 times 27 gives you 108, over 16 times 2,187 gives you 34,992. Okay. And then if you were just to plug that into a calculator, 108 divided by 34,992, it would roughly give you, so I'm not going to put the equal sign, I'm going to give roughly equal 0.003. Now that's what I got put into the original equation, but let's do the same thing putting into the equation that we solved for and we found the answer to by simplifying. So let's plug our variables back into our simplified equation. So instead of the 1 over x squared times y to the fourth power, I'm going to plug in for x and y again. So I'm going to say, I'm now going to say 1 over, again, x is equal to 2, so that's going to be 2 squared times y is equal to 3, 3 to the fourth. So it's going to be 1 over 2 squared times 3 to the fourth. And that's going to equal 1 over 2 squared is 4, and 3 to the fourth power gives you 324. Okay. And then that's equal to, if we simplify that a little bit more, 1 over, oops, I actually went ahead of myself there. So let's do that again. So 2 to the second power gives us a 4, and then 3 to the fourth power gives us 81. All right, now we have 1 over, and then 4 times 81 gives us a 324. There we go. And then if you were to put that into a calculator, 1 divided by 324, it's going to roughly give you as well 0.003. So as you can see, we got the same answer for both equations, the simplified equation and the original equation, which means that our simplified equation is correct, and that's your answer. Hope that helps.